Okay, let's talk about section 3.4. This is a continuation, like a very close or similar ideas at what we saw in 3.3, which is the bootstrapping. So remember, the bootstrapping is you've got one original sample, and rather than going out and doing another sample like yourself physically, the bootstrapping will pull values from the original and create bootstraps for you, like other versions of that sample. And the whole purpose of that is so that we can create confidence intervals. What's in the confidence interval calculation is standard error. Now, we've been focusing primarily up to this point on the whole idea of like 95% intervals, but there are also options for a 90% and a 99%. As we get more into chapter 4, we'll talk about what are maybe the reasons why we would extend out to a 90, like go to a 90 or 99. But for now, what I want to do is mainly focus like how do we create either narrower or wider confidence intervals, and there are formulas for them. For the 95, that's it. It's taking your statistic, doing a minus version, doing a plus version where you double your standard error. If you're ever doing a 90 to 99, there are formulas, but for our class, we're not going to need them. And actually, don't go investigate. I mean, you can if you want. What are the formulas? But for us, it's going to be a homework exercise where you use stat key to count the middle 90% or count the 99% of the middle. One thing I do want to at least mention is that if you're ever looking to get a narrower interval, the best way to do that is to use larger sample sizes. Because again, as you increase your sample size, your standard error will go down. And that's going back to the archer who, whenever there's the little bullseye, if you want to get your estimates all at least to be more clustered closely together, larger sample sizes will do that. It'll shrink your standard error down. And the reason why that's a good thing is because when we look at intervals that are more narrow, it also means we're getting more of a precise like estimates or tighter window where the parameter is. Now, one other thing that it mentions, this is not going to be a huge thing for us we are going to from time to time be checking what are known as conditions. Probably a bigger deal if you go on to stats 2 or some higher level like statistics. But they do say that before you decide to bootstrap, you should check to see that your original sample doesn't have the appearance of any like major skewing. That is oftentimes a red flag for it maybe being biased. Again, if you're trying to do like averages and proportions, you want a good unbiased sample. And when we get to chapter 5, we'll talk more about like the normal distribution, but it's there. There's a little note that you usually want to check your original sample, make sure that it's symmetric and bell shaped. Because if you do have a biased original sample, all you're going to do is bootstrap more biased samples. But the heart and soul of this 3.4 is to focus on using stat key to create 90 and 99% intervals. And if you're wondering, like, just real quick, like, why would we want to do 90 and 99s? Something like a 99 would be like you have the most confidence, you have the most assurance that whatever it is that you're trying to estimate is accurate, like as best of an estimate as you can possibly get. And the reason why you would want to maybe do a 99, like the most or the highest level of certainty, is if it's maybe something dealing with people's like health, like either it's like a new drug that you're prescribing, or maybe it has to do with like a lot of money. But again, when we get to 4.5, we'll talk more about that. So if we're wanting to do a study, and an example one here is about the normal body temperature, which usually we say that 98.6 is like what you would gauge like a baseline, like, oh yeah, you're not feeling too bad, you're right about close to 98.6. But if you're like at a 99 or 100 and a 101 temperature, okay, maybe something's off. Now, what we're going to do is we're going to take what they did, which is an original sample of 50 individuals, to see if 98.6 is a plausible value. Like, is it a reasonable value to be using to check whenever someone is feeling healthy or not? Now, what they did for us to get us started is, again, they did 50 people who were healthy. Like, it was a good day for them. And they got an original estimate. We're going to put that right here. And we're also going to real quick just do a quick check. Like, does the original sample seem roughly symmetric bell shaped? And usually that's the shape that you're looking for. If it's, we're going to call it the normal distribution when we get to chapter 5. But hopefully it's not a biased sample. But then what we're going to do is two different things. We're going to start off with what we've been doing most of the time, which is a 95% interval. At least that's what we were doing when we started chapter 3. But then we're going to do, hey, what if we wanted to be 99% sure about the estimate or the conclusion that we're trying to make? So let's do this. Let's go to stat key, bootstrap confidence interval, specifically the one that's about a single mean. And then there's the data set. There's the 50 people who they did their temperature for, body temp 50. Here we go. Let's get there. And let me open up a tab for my stat key. There it is. And once you get to the home page of StatKey, right in the middle, very top is the one that we're looking for. CI, confidence interval for single mean. Now they've already got the data set preloaded, and there it is. Body temp 50, temperature, the third one. And you'll see what the original sample suggested might be the average temperature for people who are feeling healthy, which is 98.26. You can also see that the graph, it's got the one hump in the middle. It's got a tail to the left. It's got a tail to the right. It's not like the most greatest looking graph, but this is one that we would say it's not bad. It's roughly symmetric and bell shaped. But the main thing I want right now is just that 98.26. That is the initial value that the actual sample that they did suggested might be the normal body temperature. I'll go and put the word roughly in here. Roughly symmetric, bell shaped. And then the original sample. I don't think it's asking for the notation, but I'm going to go ahead and do it. The statistic from the sample, the original sample, was 98.26, which is lower compared to 98.6. Now, let's do a 95% interval to get started. So the way we're going to do that is we're gonna have it bootstrap the original sample. So again, remember what that means, right? That means that it's gonna select values from the original sample. And if you want, take a moment. Right here's the show the data. That's the original 50 people and what their temperatures were. And StatKey is going to grab from them and make you another bootstrap sample, another bootstrap, as many as you want, but we want 1,000. So I'm going to go ahead and click it. Boop. There it is, roughly symmetric bell shaped. We've got the three options for clicking your tail, and we want the lower tail, we want the right tail, like the low value, the high value for the plausible range. So go ahead and click on the two tail. And when you do this, Stacky doesn't do the formula thing we do, the plus minus two standard errors. It literally counts 95% of your middle dots. And down at the bottom, you can see the estimate that I've got that the normal body temperature maybe is as low as 98.057, or maybe it's as high as 98.471. But look who's on the outside. Look, there's 98.6 over there where I've got my little red X's as being something that's not plausible, which is very interesting. And so let's go ahead and let's write down our 95% interval. And again, I'm going to write the 98057, 98057 as my low. And you'll have something similar. And it's mainly this one that here that I'm really interested in. I've got 98.471, 98471, 98. And at that point, it's suggesting that if it's probably as high as 98.47, that 98.6 is not plausible. Like it's on the outside of that. But that was only with 95% certainty. So let's switch it to 99% certainty. And so all that you're going to do is change the 0.95 that's in the middle to 0.99, and it'll widen it for you. So right there in the middle, where you see the 0.95, go ahead and click on that, and then retype 0.99. And you'll see that it's going to get even wider of a graph where the red dots are. So here I'm going to do 0.99. So this is the highest level of certainty that we're using for what the plausible temperature is for someone who's feeling healthy. Down at the bottom, I've got 97.979. Let me go and write that down. 97.979. 97.979 is as low as what it might be. And then for the highest that it might be, there it is. I got in the bottom right corner, 98.556. 98, oh, excuse me, 98.553. Now, again, you'll have something here that's similar to this, but I bet you that it doesn't have 98.6. That 98.6 is on the outside of what's plausible. I'm going to write my 98553. 98553. Now, you can do what you want with this, right? Like, wait, what are you saying that 98.6 is not a good estimate to use for people's normal body temperature? That is what the interval is saying. The 98.6 doesn't make sense. It's too high of an estimate. And it could also be that, the scientists, I remember looking up who it was. It's maybe like a dated value, right? Maybe it's outdated. And that maybe as a society of people that we've cooled off, so what we're going to do in terms of like the conclusion for this example is I'm going to jump down to E, which is 98.6 plausible? No. 98.6. And the reason why it's not plausible is that it's not in the interval. It's not in, or you could say it's not between, it's not within the interval estimate, or you can also just say it's not in the CI for short, the confidence interval. And then we've done some of these already, which is that when you're doing your interpretation, you always start off with the level, and we're going with this one, the highest level of confidence. We're 99% confident. And then this is where you would say this study was either about a mean or about a proportion, or maybe the difference between two groups. But this one was just about mean or average. Then you want to mention the variable, body temperature. And then you want to mention like who the study was about, people that are healthy. And again, you're not required to put the word all, but I'm not going to require, but I don't think it's a bad idea that this was not just about the 50 people. The 50 people were used to try to give us an idea about all healthy people. And then all I'm doing there is just putting my one that was with 99% certainty that we're 99% confident the mean body temperature of all healthy people is between, sorry, I forgot the word, is between 97.979 and 98.553. Of course, if this was like the homework problem and you randomize things, you would get slightly different answers and you would put your interval there. Yeah, again, just maybe 98.6 is a number that we need to think about adjusting. But of course, if anyone really wants to scrutinize this, maybe one of the better ways, even more um, viable way to also check, and the bootstrapping is not bad, right? The bootstrapping is a nice method to as a quick way to check to see what's plausible or not. But if anyone really wanted to scrutinize, like I don't believe it, then try it, right? Go out, find 50 healthy people, collect their temperatures, and repeat, right? Put it into Stacky and see if 98.6 lands in the interval. I'm kind of curious myself to do it as well. Now, also 50 people, if you're wondering about that, and you're thinking like 50 seems kind of low, what we'll talk about in chapter 6, section 2, is that they usually say the magic number to get at least a pretty good like distribution that's symmetric and bell shape is at least 30 people. So yeah, 50 was not a bad number to use. But again, well, I'm jumping ahead. We'll talk more about that in chapter 6. Last thing that we're going to do is just an example that switches things up a little bit. It's going to have proportions instead, and it's also going to have two groups. So in this one, when we said that there's two groups, this was a study where they were comparing uh, the opinion of women versus that of men, and the variable was whether they would support and be in favor of a gun control law. Now you can just for yourself think like, do you feel just in your own everyday discussions, conversations, watching the news, feel like maybe there's going to be a difference between whether you're male or female favoring gun control? I mean, think about also this one here, like political parties. I mean, we've got Republican, Democrat, two of the major parties. Like, is there a difference in being for or against gun control? I mean, I think we would say yes, right? But let's see what a sample says. All right. So we're going to do a 90% confidence interval for the difference in proportions of women versus men who would support gun control. Now, in this one, they don't give us what the information is. They don't tell us how many women were surveyed and how many said yes, and how many men were surveyed and how many said yes. That's okay. We're going to get it from StatKey. So here's what I want us to do. I want us to go to StatKey, and we're going to go to difference in proportions because we've got two groups. The data set's going to be there. It's going to be called support gun control law by sex. And then a couple things before we actually do it. They're going to want two notations. They're going to want one notation for the statistic, which would be the sample, and then they're going to want a notation for the parameter, which would be the population versus the sample. So I want you to take just a moment before I spoil it for you. Um, if we're doing two groups and we're doing a difference, and A is focusing on the proportion of all female and male, and the B is doing just the sample of people who are in group one versus people in group two, like what would we use? Now, I'm not going to do it yet. I want us to go ahead first, go to StatKey, and actually see what were the results of the study. So we're done with this one. And again, just remember anytime that you use StatKey for part of a homework, you need to make sure to get the credit for that problem. You need to attach your StatKey as evidence that, hey, I went to StatKey and actually used the tool. Here it is, difference in proportions. It's the fourth one down. And we're going to be looking for the support gun control law. There it is right there, kind of middle-ish, support gun control law by sex. And then right over here, you can see the results. For female, it was about 82% who were in favor of supporting a gun control law. And then for men, it dropped down to about 61%. So the main thing we're after there is at 21. That was about 21% higher in favor of females supporting a gun control law. So there was a difference, about 21% difference. So let's go ahead and just copy that information down for B. Okay, right here, I'm going to put the notations in just a second. So for female, it was 824 minus 612 with a difference of 21% being higher in favor of the female. Now, here's the notations. Since we were doing two groups, we're going to need two proportions, and we can use F for female. That's the first group, the higher group, minus the proportion for the males. That's the second group. But because these were based off of samples, we would need to put the hats on here to indicate to our audience that these were sample proportions or just based off of only some of the population. And then big cousin to that would be we were trying to do an estimate, or they were trying to do an estimate for the proportion of all female versus the proportion of all male. And then the minus sign is just that we were trying to check to see if there's a difference. Now we could do the calculation version that we do, the plus minus, but this one we're just going to let Stacky do it. And we want to do a 90% interval. So the main thing we're going to do is we're going to, we're going to have our bootstrap of our 1,000. We're going to click the two tail, and then we're going to adjust it to a 90%. All right. So once we've got our data in there, we can click our generate 1,000. That's going to bootstrap it. So now, boom, just like that, magically, we've got 1,000 more. We're going to click our two tail, which I've already done it. And it always defaults right here in the middle to a 95%. You cannot forget for this homework that for 3.4, we're adjusting to 90 and 99. So you'll click on that blue box and you'll switch it to 0.90, which is going to make the graph more narrow. And so with 90% certainty, the difference between male and females favoring a gun control law is somewhere between, I've got 0.165 as the low to as high as 257. So I'm going to write those real quick. 0.165 is my bottom, my lower left, 0.165. So you'll have something similar. But make sure in order for it to be really, really similar that don't leave it as the 95% here. Switch it to the 90. And then I've got 257 as my bottom higher value for the estimate, for the parameter, 2.57. 2.57, oops, 2, right, 0.257. I'm going to double check that. Yeah, 0.257. Okay, good. Now, the that's the interval suggesting the difference between the groups. Now, keep in mind that this 0.212, maybe we'll just put it right here, was this idea that female is higher by about 21%. All that these are doing is suggesting that female is still higher, just maybe not as much as 21%, maybe like 16% or even more, maybe like 20, 25, 26% higher than male. So we'll do D in just a second, but what E is asking real quick is like, is it plausible that there's no difference? Or in other words, that the two groups match and that they both would equally be likely to favor a gun control law? And I want you to just think about what no difference is. Number wise, that's a zero. And so another way to think about this question is zero in the interval? No. Right? Both of these are arguing in favor that female are going to be the higher of the two groups. So no. And when you do your homework, I want you to be real specific about the number zero. And the reason why is because later on in the semester or in the later parts of the course when we're doing hypothesis tests, zero is going to be a very big deal. Okay. Zero is not contained in interval, so the idea that there's no difference between these groups doesn't make any sense. One group is higher than the other. And that's also different about this section. Rather than say 95 now in some of these examples for 3-4, it's going to be either 90, 99% confident. And then all I'm going to do here is really just reuse their words, right? This was the goal to talk about the difference. That's what the intent or the purpose of the interval is to tell us what's the difference in the proportion of women who would support a gun control law versus men who would. So you can just reuse those words, or if you feel like paraphrasing it a little bit, that's okay. But sometimes when trying to paraphrase things, that might just lead you to leave out important details. Now, the tests are never going to be so long that you're running out of time and that you won't just have enough time to just go to just be more specific and write it all out. That the difference in proportions of women who support a gun control law and men who support. I just went big here. I just went ahead and like, I got the time. I'm just gonna go and just reuse their words and get it all in there. But for sure, we can't forget this to talk about what the interval suggested, where the difference might be something between 0.165 and 0.257. And I've mentioned before, if you want to switch that to percentages like 16.5% and 25.7%, you're more than welcome to. So definitely a shorter section there, but I would definitely just take note that the 3-3 and the 3-4 homework assignment combines both of these together. So that'll just be one assignment, one grade for 3-3 and 3-4 homework together. So I definitely encourage you to just make note of that. But that is it. And then also, of course, yeah, this section right here, when you do the homework, make sure that in order to do things accurately and get good answers that are going to match close to the answer key, that you change things from the 95% to a 90 or 99 as instructed. All right, I'm going to go to end things there. And of course, as always, reach out to me if you run into questions. Take care.